Greetings to all. I hope you are all staying safe. Myself Adasha KS, working as a lecturer in Government Polytechnic, Nagamangala. I welcome you all for the useful and most beautiful videos on different experiments of electronic servicing lab. In the previous session videos, we learned many concepts of this lab like different external components of a computer, internal parts of a motherboard and many things. In this video, we are going to learn servicing part, that is the first experiment of part B. This part B is specially dedicated to learn the different concepts related to servicing. So the name of the experiment is Safety Precautions to be taken while servicing the equipments and the tools required for servicing the equipments. So if we start with the agenda of this session is, the first concept we are going to deal is safety precautions to be taken while servicing any equipment. Second one is, what are all the tools which are required for the effective service of any equipment. And the last concept of this session is how to identify the faults in the digital ICs, and after identifying, how to troubleshoot the faults in digital ICs using logic probe. Now we'll move on to the first concept of this session. The concept is, what are all the safety precautionary measures we should take while servicing any electronic equipment? Here, safety comes in the two aspects. One is general safety and the other one is personal safety. What are all the general safety measures we should take while servicing any electronic equipment? The first point is with respect to power source. Always remove any electronic equipment from the main power source before working on it. Never assumes that power circuit is off. Test and test again with the voltmeter to confirm. Remove fuses and replace them only after power circuit is grounded. Don't connect power circuit until you are done working on it. Recheck the work, then only you connect to the power source. Always ensures that electronic equipment is properly grounded. If it is damaged, replace it. For instance, replace cable instead of repairing with insulating tape. Always use the right electronic repair and maintenance tools. And returns covers after removing them to reduce the risk of electric shock. And most importantly, always have safety equipment like fire extinguisher, basic first aid kit nearby. And the main importantly, while servicing equipment, when some IC burnt, when smoke appears, we should ensure that we should cut down the main power source by switching off the DP. These are the general safety measures we should ensure while servicing any electronic equipment. Next, what are all the personal safety measures we should ensure while servicing the electronic equipment? The first personal safety measure is we should always keep our servicing area dry. It should not be wet. Second point, we should work in a well ventilated area. That is, sufficient light and air should get into the servicing area and get out of the servicing area. That is the best safety measures we should ensure. And the third point, while servicing, we should not use loose clothes. And the fourth point, please ensure that you are not wearing any metallic equipment like jewelry on your hands, like watches, rings, bracelets, because you know that metal is a good conductor of electricity. There may be chances of getting shock through this metallic equipment like watches, rings and bracelet. So fourth point is, please remove all this metallic equipment like watches, rings and bracelet. Fifth point, don't use bare hands when removing hard parts. Always wear insulated gloves in your hands while carrying a repair works. Next, always wear non-conductive shoes. That is the best idea. Next, when removing high voltage charges on capacitor, always use a shorting stick. Next, always remove power to a circuit before connecting alligator clips. Use safety goggles. Last point is, before removing any capacitor, especially be careful when handling a large capacitor, as they can still hold a high voltage even after you have disconnected the power from the circuit. So these are all some of the personal safety measures we should take while servicing any electronic equipment. Second agenda of this session is learning different electronic repair tools. The different electronic repair tool you can see in the video is multimeter, screwdrivers, wire stripper, long nose plier, cutting plier, scissor, tweezer, flat head screws, soldering set. First, we'll concentrate on the multimeter. It is an electronic tester used to measure basic electrical quantities like voltage, current and resistance. Since the measured values are digital in nature, it is very easy to record the quantity. It has got two probes. One is in the red color, other one is in the black color. Multimeter has got three ports. One is called common port, and this port is always connected with this black color port, and the other one is red color probe. While measuring the voltage or resistance, we should connect this red color to this voltage port, or if we are measuring current, we should connect to this port. And it has got different ranges. If we are measuring voltage which is in DC nature, we have to connect this knob across this range, and remember the probe connection should be to this port. And if you are measuring current, the probe should be in this port. Okay, and to measure current you have to go with this ranges, and to measure AC voltage you have to keep the knob at the voltage across AC, and probe should be in this. And if you are measuring resistance, you have to keep the knob across these ranges. And this pointer used to hold the component or to the point where you need to actually measure the quantities like resistance, current and voltage. This is very important electronic repair tool we use while servicing any electronic equipment. Next, the second important electronic repair tool is this soldering set. This is called a soldering gun or soldering rod or soldering iron, we call it as. And this is a soldering stand, and this is a lead. Soldering is nothing but a process of joining two ends of electrical or electronic equipments by heating this soldering rod to a temperature of 600 degree Fahrenheit. And we use this soldered, which is made up of tin or lead, to the process of soldering. And the third repair tool is this. This is called as wire stripper. Wire stripper is used to strip off the wire insulator from its conductor before it is used to connect to the another wire or soldered into the printed circuit board. Some wire stripper has a measurement engraved on it to indicate the length of the wire to be stripped off. It is used to remove the insulator part of the wire. Okay, next. And the fourth one is this. This is different screw drive heads to remove the case box of any computer CPU cabin. You can use different heads, and just you need to take off this and you need to place at this part, and you can easily remove the cabins of a CPU. Okay, and this is a flat head screw drives. See, this is a handy device. Just you need to take this and you need to place across this by loosening this part, and you need to place across this, and this is a flat head screw drives. Okay, and now this is a long nose cutting plier. Long nose cutting plier is used to hold the component which is very small, and it component which is very hot when we are soldering onto a PCB board. And one more type of cutting plier is this side cutting pliers. It is used to strip off the wire, and it is used to cut the extra part of any printed circuit board. And scissor, it is used to cut any other parts or extra parts. And tweezer, it is used to hold very small and tiny component. And pocket knife, it is used to cut down the parts. Last concept of this session is identifying the faults in digitalizers and troubleshoot it using logic probe or digital IC tester. Identification of faults in digitalizers involves three main steps. First one is fault detection. Second step is fault isolation, and the third one is fault correction. What is fault detection? How to do it? First, we should observe the circuitry or complete system very clearly for its system operation. And we should compare it with the expected correct operation. For example, if you are checking AND gate IC, the output you should get it as for input 0 0 output is 0, for input 0 1 output must be 0, for input 1 0 also output must be 0. Output should be I or 1 only when both the inputs are high, that is when both A and B are 1 1. If you are not getting this output, it is understood that there is some fault in the IC. So this is the way of detecting the fault. Simple thing is, we should compare the output with the expected result. This is the most important step in identifying the fault. First one is fault detection. I hope you are clear with the fault detection part. And the second one is fault isolation. We should perform different tests and make measurements at different level to isolate the fault. Isolation is nothing but fault separation. Next, after this, after confirming with the fault, we have to correct it. How to correct the fault? Simple as we have to replace the faulty component and repair the faulty connections and remove the shorts if there are any shorts in the ICs. If I summarize, any IC identification of faults includes fault detection, fault isolation, and last is fault correction. Next, the most common internal failures of digital ICs are, first one is there may be malfunction in the internal circuitry. Sometimes malfunctions in the internal circuitry also leads to the faults in the digital ICs. Second cause is sometimes maybe input or output are shorted to ground or to VCC. And the third, inputs and outputs may be open circuited and there may be a short between the two pins other than the ground and the VCC. So, to overcome all these four types of internal failures in the digital ICs, we should troubleshoot the ICs using digital IC tester or logic IC probe. The picture you are seeing on a screen is a simple logic probe. We are going to troubleshoot our IC problem using a logic probe. What is a logic probe? Logic probe or a digital tester is normally a low cost handheld probe contained within a pen-like tube with indicator lights to show the state of line being probed. The logic probe has a pointy metal tip that is attached to the specific point you want to test. As you can see clearly in the figure, it is a pen-like structure. It has got a display part. In this display part, you can see three different colors of indicators. The one indicator is to indicate logic high state, and the second indicator is to indicate logic zero state or logic low state, and the third indicator is to indicate the fluctuation between low and high state. This you should observe on the display port of the logic probe or a digital tester. And it has got pen-like tube-like structure where we use this point to place it on the exact IC point where you need to test the IC. And it has got two extra probe connection. This probe connection, one probe end is given to VCC and the other end is given to ground. By using this digital tester or logic probe, we can easily troubleshoot the problem associated with the digital IC tester. In this session, we started with different precautionary measures we should take while servicing any electronic equipment. We learnt what are all the general safety measures, what are all the personal safety measures we should keep in our mind while servicing electronic equipment. Secondly, we learnt different electronic repair tools like multimeter, vice stripper, cutting pliers, many things. And at last, we learnt identification of faults and digital ICs and how to troubleshoot using digital IC tester or logic probe. Thank you.